With a focus on bridges, I will illustrate 1. How engineering is a creative discipline and can become art. 2. The influence of the economic and social context in bridge design. And 3. The interplay between forces and form. I will use examples of real bridges and real people to lead you through the fundamental principles of bridge engineering and examine the history and evolution of bridge design. In the short time frame that I have, it's not possible to include all important bridges and important engineers in this course. Please read The Tower and the Bridge by David Billington to gain a deeper historical perspective. This book was published in 1983, so to give you a more modern perspective, I end the course with Modern Bridges of Spain as just a small example of current times. One major theme that runs through each lecture is that engineering is a creative discipline. Engineering creativity requires courage to try new things, discipline to stay within the boundaries of rational forms that lead to efficiency and economy, and creativity also requires play to search for a proper form that is not only technically correct, but also elegant. The course has several learning objectives. By the end of this course, you will be able to 1. Recognize structural art, and for the important structures studied in the course, be able to identify the name of the structure and engineer who designed it. 2. Solve for the efficiency of structures using appropriate formulas. 3. Evaluate the success, or not, of a structure within the measures of structural art: efficiency, economy, and elegance. And 4. Illustrate how economic, social, and cultural context influence the design of bridges. You will also learn about different bridges' structural forms, including suspension bridges, beams, pre-stressed bridges, arch bridges, cable-stayed bridges, and tied arch bridges. For each of these forms, you will develop an understanding of how the loads supported by the bridge travel through the different parts of the bridge to the foundations. The course is designed for a general audience. No engineering background is needed, and the teaching consists of lectures, which focus on social and symbolic aspects, structural studies, which focus on the scientific aspect, and online questions. The structural studies, which are about 5 pages long, will guide you through some fundamental equations of statics and equilibrium to calculate the forces imposed by the weight of traffic and the weight of the structure itself. Course participants with stronger technical training may find the calculations in the assignments too simplistic, but these formulas are not watered-down versions of what engineers use today. They are the fundamental equations used by every engineer to analyze and design bridges, in particular in the conceptual phase of design. In the lectures, I will trace the development of outstanding bridges that arose with new materials that were developed after the Industrial Revolution, such as industrialized iron, then structural steel, then reinforced concrete, and finally pre-stressed concrete. With each new material comes a new relationship between forces and form. For iron and steel, we have smaller members and therefore challenges of buckling or stability. With reinforced concrete, we have the relationship between the steel and the concrete. And with pre-stressed concrete, we have the challenges of what's called creep that you will learn about. To start this historical perspective of form, we need to travel to Great Britain, where one can argue that structural art began. Therefore, we begin our lecture series with Thomas Telford and British metal forms. I hope you'll join us.